Hello guys, Dr. AJ. So we have 4 examples on field and lab tests. It's part of the soil mechanics and they are common in the FE and the PE exam. So let's get started. The first example we have, as you can see, direct shear test was conducted on sand. It says please pay attention. Sand soil. Determine the angle of internal friction phi from the following data. Sometimes it's pronounced as phi, sometimes it's pronounced as phi. Sample area is given 20 inch square, normal load 550 pound, and shear stress at failure 18 psi. So as usual, we start the solution by putting what is given. Sample area 20 inch square, normal load, shear stress, all are given. What we're going to be using is the Mohr-Sokal shear stress, normal stress relationship. So here, that's how it looks like in your manual, in the FE manual. So C basically is the cohesion, and this equation in our example is 0. Why is 0? Just because we're dealing with sand. So that means tau is going to be equal sigma tau phi tau over sigma. So phi basically is the tan inverse of tau over sigma. Tau is given 18 psi. Sigma is the normal stress. We don't have that, but what we have the normal load 550 and we have the area. So sigma is basically P over A. The normal load 550 over the area 20 inch square, we're gonna get 27.5 psi. Now we have everything. So now we have everything. 18, the shear stress, 27.5 sigma. So that tan inverse for that, we're gonna get 33.2, the angle of internal friction. So the closest thing is 33, so the answer is B for this one. Example 2. So we have a soil, and then we're looking for the relative density. Porosity is given 30%. Emax, which is the maximum void ratio, 0.8. Minimum void ratio is given as well, 0.2. We're looking for the relative density. So we start the solution as usual. We put what is given, 30% N, E maximum 0.8, E minimum 0.2. We go to your reference manual, we're gonna see relative density has 2 equations. One based on the void ratio, E max, E and E minimum, and the second one based on the gamma dry, field, the maximum minimum. So we're gonna be using the green one based on the E, since that's what we have. Now, we have E maximum and E minimum, but we don't have E. But what is given was the porosity. So from the porosity, we can find E. Go back to your reference manual, we're gonna see the porosity has the equation E over 1 plus E. That's what we're gonna be using. So we do a little bit math. Since we know the porosity, we can find E. In this case, we're gonna end up having an E of 0.43. So now everything we need is pretty much available. E maximum 0.8, this is 0.8. E, we just found that 0.43. E minimum 0.2, and that's gonna give us 62%. Oh, please pay attention. One of the good things I want you to pay attention to is when we found E, it was 0.43, so it was between E maximum and E minimum. So if you got a number higher than the 0.8 or lower than the 0.2, just know that you did something mathematically probably wrong. So relative density is 62, and that's going to give us basically option C. Example 3, we have soil sample, total volume is given 0.01 cubic meter, solid weight 0.16 kilonewton, so we're dealing with SI units. Minimum dry density is 11 kilonewton. Relative density, this is the keyword, is given, but we're looking for the maximum dry density. Okay, so as usual, we start writing down what is given: total volume, weight of solids, relative density, gamma dry minimum. We're looking for gamma dry max. So we go to the relative density equation, the key, and we know there are 2 equations, but this time we're going to be using the green one because that's what's given. We write down the equation. Gamma dry in the field, we don't know that, but we have the weight of solids and the total volume. We can find the gamma dry from that. Gamma dry minimum 11, it's given. Gamma dry maximum, this is basically what we are trying to find. Gamma dry minimum, again, we know that. Gamma dry in the field, we're gonna find them from these. And relative density is given. So first, we find the gamma dry in the field. Weight of solids over total volume. This is basically how it looks like in your manual. Weight of solids over the V. When they put V, but it means the total volume. So sometimes they put T, sometimes not, but just easier for you to put the T letter so that you know it's just the total volume. So weight of solids 0.16 kilonewton, total volume 0.01. That's going to give us basically 16. Now we just plug in the number 75. We keep the 100, so you can use 75 as a percent. Gamma dry 16, we just found that. Gamma dry minimum 11 from here. Gamma dry maximum, what we're looking for, 11 again for the minimum, and then 16 and gamma dry max what we're looking for. So a little bit mathematics, and now we're gonna get gamma dry maximum of 19 kilonewton per cubic meter, and that's gonna give us option D. So example 4 and the last one. So we have a soil sample, solid weight is given 6 kilonewton, weight water content 10% is given to, maximum or lab dry density is given 20 kilonewton per cubic meter. Relative compaction, this is a keyword, it's 98% and it's given. And then what is most nearly the volume of solids? So we're looking for the volume of solids. Okay, but the keyword is relative compaction. So we start the solution writing down what's given, weight of solids, gamma dry maximum, water content, and relative compaction. Again, we start by relative compaction is gamma dry field on the gamma dry max times 100. We have 98%, this is here, 0.98. 20 gamma dry maximum is given, so we're gonna get the gamma dry in the field, and that's how it looks like in your manual. We're gonna get gamma dry in the field of 19.6. And now from the gamma dry in the field, we all know is the weight of solids over the total volume, right? And that's how it looks like in your manual. So gamma dry in the field 19.6, we just found that. The weight of solids is given 6. So we're gonna get the total volume. We're looking for the volume of solids. So the total volume, we found that, but we need the volume of water now. Okay. So the total volume 0.3, we're done with that. Now we're gonna be using the water content in order to find the volume of water. So that later we can subtract the volume, the total volume from the volume of water to find the volume of solids. Okay, so the water content is 10%. 6 is the weight of solids. The weight of water, we're gonna get that. So that's gonna give us 0.6 weight of water. And again, this is how it looks like in your manual. So we have the weight of water now. So gamma dry in the field, we found it. Total volume, we found it. Weight of water, we found it. Now, in order to find the volume of water, we know the density of water, and we know density is basically weight over volume. So what we're gonna do, we use the density equation to find the volume of water. Density of water 9.81. Please pay attention, it's SI units. That's why we're using kilonewton per cubic meter, 9.81. Volume of water is what we're looking for. Weight of water 0.6. We just found that from the water content equation. So we're gonna get the volume of water out of this, which is 0.061 cubic meter. Now we know the volume of water and we know the total volume. We can find what we're looking for, mainly the volume of solids. So 0.3 minus 0.061, we're gonna get almost 0.25. And that's gonna give us option A. So with that, thank you very much and see you next time.